Hello everyone, and welcome to the RDD Transformations and Actions lecture. In this lecture, we're going to begin to dive deeper into using Spark and Python. There's important terms and definitions that you can check out in the Jupyter notebook that goes along with this lecture. I'm going to go ahead and jump to that notebook now and walk you through a few of them. Alright, here I am at the notebook that goes along with this lecture. I just wanted to quickly go over some important terms that we've reviewed before, but here's just a refresher. Remember that an RDD is a resilient distributed data set, and we have transformations and actions. A transformation is a Spark operation that will produce an RDD, while the action is a Spark operation that produces a local object. So you can think of a transformation as just a set of instructions, basically a recipe to follow, that will produce an RDD. However, until you call an action, you're not going to get some local object as a result that you can then either view or play around with. And then finally, a Spark job is the sequence of transformations on data with some sort of final action. So a Spark job is just the RDD that you have a transformation and then call an action on. That's all three of them combined. There's a few common ways to create an RDD. There's sc.textfile, where sc is that Spark context we saw earlier. So if you want to create an RDD of lines from a file, you can use sc.textfile, or if you're dealing with some sort of elements of array or maybe a list, you can also use sc.parallelize. And then we have transformations. So we've actually seen the filter transformation earlier, but you have quite a few examples that are available to you. And these are some of the transformations that we're actually going to be working through and showing examples through this lecture. Some of the more common ones are things such as filter, which will discard elements that don't return true depending on what lambda expression or function you pass in. Then you have map, and there's a couple of examples here. So for instance, if you wanted to multiply each RDD element by 2, you could use that second example, or the third example of map will split each string into words. Then you have flat map, and remember the difference between map and flat map. In this case, this flat map will split each string into words and flatten out a sequence. You also have sample, which is another transformation. Sample just creates a sampling with replacement, and you can actually specify whether or not you want with replacement to be true or false, and then you can specify what percentage you want to sample of the entire RDD. So it's just a way to take out a sample of certain elements from the original RDD. Then you have union, which can actually append an RDD to an existing RDD. You have distinct, which removes duplicates in an RDD, and you actually also have sort by, which will sort elements in either ascending or descending order, depending on what parameters you pass in. So those are just transformation examples, and we're going to walk through a lot of those today. And then we have RDD actions. So once you have that recipe of transformations ready to go, the next thing you're going to do is execute them by calling an action. So some common actions are collect, which you've actually already seen before. It just converts the entire RDD into an in-memory list. Then there's take, with some n number passed into it, which takes the first elements of the RDD. There's top, which takes the top elements of the RDD. Maybe you want to use that after you've sorted. There's also take sample, which creates sample of 3 elements of replacement. In this case, because we passed in 3 for n, and with replacement equals true. And then there's sum, mean, and standard deviation, which basically do what they say. All right, so the best way to show all of this is just through examples. So what we're going to do is work and create through all the examples here in the notebook, show you RDDs, show you key value pair RDDs, etc. And we're actually just going to work through all of this. So let me go ahead and jump right back to an empty notebook to get started. Okay, so let's actually create a text file to work with. We've done this last time, but you can just say write file, example, let's go ahead and call this example2.txt, and I'm going to write first, second line, the third line, then a fourth line. So I'm going to run this cell to actually create that text file. Here we have writing example2.txt. Let's go ahead and perform some transformations and actions on this text file. To get started, I'm going to say from PySpark import Spark context, run that, and then I'm going to say sc is equal to Spark context. Then I'm going to go ahead and show the RDD by saying sc.textfile, and I'm just using tab autocomplete there, and I'm going to pass an example2.txt. So here I can see the actual RDD, where it describes it as a map partition RDD at text file at some sort of location in Java. in order to actually save a reference to this RDD, we can go ahead and make another object. We'll call it text underscore RDD is equal to SC text file, and then pass an example again too. Let's run that. Okay, so now we actually have a reference to the RDD, but I just wanted to show you what it actually looks like if you just say that by itself. Let's go ahead and map a function or a lambda expression to each line and then collect the results. I'm going to go ahead and say text underscore RDD and do a transformation on it. I'll say lambda line and then go ahead and line split. So far I just have a transformation that will split everything, every line there, to a list of words. So I'm going to call this words, run that, and then notice words doesn't do anything until I actually perform an action on it. So I'm going to say then words.collect. This may take a while depending on your connection, but there it is. If I just take a look at my original text RDD and call collect on it, notice the difference here, where here I said split every line into a list of words. If I just call collect on the original text, I actually get each string line in that list. So notice the difference here between mapping this line.split expression versus the collection of just the original RDD. All right, let's go ahead and explore map versus flat map. So if I wanted to collect everything as a single flat map, I could use the flat map transformation. So I can say text underscore RDD dot, and instead of saying map, I'm going to say flat map. And I'm going to pass in the same lambda expression for every line, take it in and split it. And I'm just going to go ahead and call collect on that. So notice here on this previous example, I separated this into a step, my transformation step, and then my action step, but you can actually just put it all in one line if you want. It's up to you. You're not wasting any memory by splitting this up into multiple steps, because remember, nothing actually gets evaluated until the final action call. Let's go ahead and run this and see the difference. All right, so this is with flat map, the exact same expression, except instead of using map, we're using flat map. And look what happens here. We actually collect everything as a single flat map. So now we just have one single array or one single list of all the words in that text file. Okay, so now that we've worked with just these text RDDs and how to aggregate values with them, what we're going to begin looking for is key value pair RDDs. And in order to do this, what I'm going to go ahead and do is create some fake data as a new text file. Now, if you go back to the notebook for this lecture, here we just finished the map versus flat map section. There's a cell here with the actual text file information. You should probably just copy this and then paste it back into a cell here. That way you don't have to spend any time writing all of this. So I'm just going to run this. And this is a services.txt file. This basically looks like just a typical CSV file. We have an event ID, some sort of timestamp for that event, the customer that did some sort of purchase at that event, the state they did the purchase in, what service they purchased, so that service has an ID, and then the amount in dollars of how much that service cost. Okay, so this, we can just pretend that this is some data that represents services sold to maybe some sort of software as a service business. We'll go ahead and say services is equal to sc.text file, and we'll say services.txt. Run that. All right, and usually when you're dealing with some sort of more complicated text file like the one we have here, you'll probably have to clean it or manipulate it in some sort of fashion. Let's go ahead and just grab, using take, the top two lines of this RDD. So here we have basically the header and then the first line of data. Notice right now that it's all just a single string per line. Let's go ahead and explore just splitting this up using map. So I'm going to say services.map, lambda, take in a line, and then split that line. And here I have, again, that Python RDD. So nothing's going to happen until I actually call an action on this. And since map is just a transformation, I need to call an action on it to actually see the results output in some sort of local object. So I'm going to take the top three results of this. So we can just say .take3, run this, and we can see here we begin to actually transform this string as every item in this list to an actual list of items. So now we can actually get some separation between each variable in the columns. Now what we want to do is maybe try removing this hashtag here. We don't want hashtag event ID, we just want event ID. So let's go ahead and explore how we can do that using this RDD Transformation Action methodology. First thing I'm going to do is map lambda, and let's go ahead and say line, and I'm going to grab everything from index 1 forward if the first element of that line is equal to a hashtag. Else, I'm just going to return that line. And then I'm going to collect the results and see how it works. Okay, and that worked perfectly. We were able to remove that hashtag. Basically, all I said was, going back to this original services, check the first item of every string. If it's a hashtag, make sure to remove it by grabbing everything beyond it. If it's not, just go ahead and return the entire line. That's all I was doing here with this lambda expression. So you can see the flexibility of a lambda expression. They can actually be quite precise in what you want to do. So now that we have that, I'm going to go ahead and then do this same map call of splitting it up. So I'm going to not collect this yet. I'll call this clean, run that, and then off of clean, I'm going to say clean is equal to clean.map, and then I'm going to map the previous thing that I did here in order to split everything. So I'll say lambda line.split, and let's go ahead and run that, and then I will say clean.collect. And there it is. Now we have our previous services mapped to a list of items, and we no longer have that hashtag. All right, now that we've seen the basic transformation action relationship that we can use, let's go ahead and begin to use methods that combine lambda expressions using a by key argument. And these by key methods will assume that your data is in the form of a key value pair. This is a reference back to those pair RDDs I mentioned back in the Spark overview lecture. Let's go ahead and check out clean one more time here by saying clean.collect to see the data we're working with. All right, let's go ahead and start by practicing how to grab fields. For instance, let's go ahead and explore how we could get the total sales per state. Meaning I want to know how many sales in the amount column were for New York. So I kind of want to do this group by, but it doesn't work exactly like that with Spark. You're going to have to use a reduce by key statement. First thing I'm going to do is just say clean, and I'm going to map, and I just want to grab these fields, the state field and the amount field. So I'm going to say lambda, and then there's a line. And remember, that line is a list. So if you want, just to make it very clear, I'm going to say LST. And then I'm going to return a tuple. And I want to grab the state column and the amount column values. So if we look at state, that's 0, 1, 2, 3 in those lists. So I'll say LST of 3. And then the amount is the last one. So I can actually just use negative indexing to grab that last item. And then I'm going to go ahead and show you what this looks like by calling collect on it. And there you have it. Now you have a list of these tuple pairs. And that's exactly what we need for these pair RDD commands to work, which is going to be the reduce by key statement. So now, after collect, what I'm going to go ahead and do is just delete that. And I'm going to go ahead and call this pairs equals clean.map. So go ahead and run that. And then I'm going to say pairs, and I will use the method reduce by key. And reduce by key takes in a lambda expression, and it assumes that you have your data already in the tuples form. So I can say amount 1, amount 2, colon, amount 1 plus amount 2. Whoops, AMT2. And if we take a look at, I just want to show you what pairs looks like again, so I can explain this clearly. If I look at the collection of just pairs by itself, what reduce by key does is it assumes that the very first item in this tuple is the key. and it performs this lambda expression as a reduction off the second item. So it automatically assumes that you're going to use this first column, in this case state, as the key. So I'm going to call this rekey, so reduce by key. And then off rekey, I'm going to say collect. And here you can see that the amounts are actually still strings. So this didn't quite work exactly like we expected it to. So we have the lambda expression working correctly. We are adding the amounts together, but it's concatenating strings, because if you notice here, we can still see single quotes. So that means these are actually still strings that it's concatenating together. So it's actually adding 100 and 750 as concatenation of strings instead of actual numbers. So let's go ahead and fix that. And you can fix that by just converting these two amounts to float here. And this is the kind of thing you're going to be doing often with Spark, kind of filtering through your data, cleaning it, and then step by step through each transformation, check back and make sure you fix things to get it in the way you want. So now if I run that and run rekey again, I get exactly what I wanted, which is the total sales per state. And that uses the reduce by key method. Again, in order to use the reduce by key method, you need to have your data in a format that looks like this, some sort of key value pair with these tuples. And you can do that by using map on your data and grabbing whatever tuples you want for the columns of data. Let's go ahead and continue our analysis by sorting this output. So I'm going to grab the state and amounts, add them, then get rid of some columns and show you how to do all this. So I'm going to basically start from clean. So I'm going to say clean. Let's go ahead and collect that just so we can see what it looks like. So here's clean. Let's go ahead and show all the steps we're going to do. So we'll say step 1 is take clean and map lambda list and grab the tuples or the items we want and set it as a tuple. So I want the third item and the last item, and I want to return that as a tuple. So that's step 1. Let's go ahead and make sure that works out correctly. So step 1 is just grab the state and the mount, and we'll grab it in the form of a tuple. Now let's go to step 2. Step 2 is going to reduce by key. So we'll say step 2 is equal to step 1 dot reduce by key. And notice the capitalization there. We'll grab lambda, takes in amounts 1, AMT1, AMT2, and I'm going to return the addition of those, AMT1 plus float AMT2. And the next thing I'm going to do is go ahead and try to get rid of, if we look back, we had this states and the amounts. I don't want those. I just want these values here, the state and the total amount. So let's go ahead and get rid of those. So let's get rid of states amount titles. So then step 3, I'm going to go ahead and say this is step 2 dot, and I'm going to filter out lambda for, let's go ahead and just say x, and we'll say not x0 equal to state. And that will remove any item where your first item in that tuple is state, which is essentially just going to get rid of that first line. Okay, and now let's go ahead and sort the results by the amount. So we'll go ahead and say step 4 is equal to step 3, and I'm going to call sort by as a transformation and call it lambda. We'll go ahead and say st amount, and we'll take st amount, grab the second item at index 1, and then say ascending is equal to false. So this basically tells you, hey, sort by the second item in those tuples, and then say ascending is equal to false. And then finally, perform the action. So we'll say step 4 dot collect everything. Let's go ahead and run this. and see the results. All right, perfect. This is exactly what we wanted. It's really similar to everything we just did, but here we really broke it down into step by step. So we grabbed our data, and this clean data, remember, that was getting rid of that hashtag. If we go back up here, clean was our getting rid of that hashtag there and splitting it up into lines. Then we actually grabbed the items we wanted, returned it as a tuple. Now that it's in that tuple form, we can do the reduce by key. Then we got rid of the state and amount titles, sorted those results, and performed an action on it. So you should remember to try to use unpacking or tuple unpacking for readability. Let me go ahead and show you a quick example of that. Here we were using indexing, but a lot of times you'll want to replace that indexing with tuple unpacking. So I'm going to make a list called X, just so to make this clear. I'll say ID, states, and then amounts. A lot of times you may not be using lambda expressions here, but you'll actually define your own function outside of it using def, and then just apply your function, which helps for readability and just clears things up. So let's go ahead and pretend we were going to do that. I'll call def func1, that maybe it takes in a list, and then it returns lst -1. So that's one method you could use, which is essentially what we were doing here, right? These were what our lambda expressions were. They took in an item and returned some indexed item off of that. However, this isn't really readable if you come back to it later. So if a couple days pass by, you're trying to remember, well, what is that index 3 and what is the last index? What you will want to do is try using tuple unpacking instead. So you can say something like def. Let's go ahead and make this func2 and do something like this. We'll say id underscore st underscore amt. And that is just one object, but I can unpack the values. So I'll say id st amt tuple unpacking is equal to id underscore st underscore amt. And then return, and I can actually now return singular values here. So then I can just return the amount. And that function works the exact same way. So if I say func1 on x, remember x looks like this, that returns amounts. If I say func2 on x, that also returns amounts. But when you go back after a couple days of working on this, function 2 here is much more readable than function 1. Reading function 2, I can immediately tell what I was trying to do here. I was trying to create a function to return the amount. On function 1, all I know is I was trying to return the last item. Okay, that's it for this lecture. Make sure you go and review back to the notebook here everything we did. There's a lot of extra information here on transformations and actions that you can play around with that are really helpful for you to review. Hope you enjoyed this lecture, and I'll see you at the next one. Thanks, everyone.